Hello everyone, thank you for joining in this video. My name is Amirsin Ahrari. I'm a Google Earth Engine expert. In this video, I'm going to show you how to make monthly Landsat images in the Google Earth Engine platform. It's a very helpful tutorial because enabling you to have access to the monthly Landsat data with 30-meter spatial resolution and doing your processing based on the monthly temporal frequency. So let's go to the Google Earth Engine platform. This tutorial, same as others, is helpful and also can be implemented for all around the world. It doesn't matter which area you choose. For example, randomly I select an area in the United States. For example, in this tutorial I select the New York City. A part of the image in this area covered by water, part of that covered by the urban areas, and a part of that covered by the vegetation covers. And also we have a variety of different phenomena and also the land covered and land use for this region. So after you select the study area by the map.center object like this, we can have a focus on our study area, which already selected by the rectangle operations or the rectangle tools actually. So map.center object and geometry inside. And then next we need to make a variable calling Landsat images. I make a variable calling Landsat data. I wanna use Landsat 8 images. And also I can show you a technique how to combine Landsat 8 and Landsat 9 together in this tutorial. It is also very helpful because Landsat 8 and Landsat 9, both of them have the same spatial, temporal, and also the spectral resolution, and enables you to provide more frequency for your analysis. But in this tutorial, the increasing of frequency is not very important because we want to make the monthly products, and that's the main target of this tutorial actually. First of all, I'm gonna call Landsat 8 data. There are a variety of products regarding to the Landsat data, but if you want to have access to ready-to-use Landsat data without geometry and radiometric or even atmospheric correction, you should use Landsat 8 Collection 2 level 2 actually. Sorry. So Landsat 8 Collection 2 level 2. Landsat 2 Collection 2 Tier 1 is a kind of product which is already corrected and included surface reflectance data and surface temperature. Just import it into the code just like that, and here we have an image collection, and then by the filter date you can define the start time and end time in your code. I make two new variables, time start and time end, that's explaining the period of time that I'm going to use for the further processing. Time starts equals to, for example, 2023. I want to make monthly images for 2023 in the periods that Landsat 8 and Landsat 9, both of them are available, but for some months maybe we missed a Landsat 9 images, and also anyway we want to collect all of the Landsat 8 and 9 together in a one single image collection and then convert them to the monthly format. So and the next is the time end equals to 2024, just like that. So here we try the code by the print, and also for the mid-latitude resolution satellite data such as Landsat with 30-meter and Sentinel with 10-meter, it's very important to use filter bound to narrow down your satellite data based on your specific region that you already selected. When you are working with coarse resolution data such as NOVA and MODIS, it doesn't matter you use filter bound or use it or not. But for the Landsat and Sentinel and mid-resolution data, it is important to use filter bound to bound your satellite data to a specific region you selected actually. So filter bounds equal to geometry. I want to use all of the satellite images for this region. When we want to convert the satellite data to the monthly format, it doesn't matter. You pick the pass and row for, and also you don't need to only use a specific pass and row for the image processing, because when we convert them to the monthly average, for example, all of the images are available in your region combined together in overlapped area and converted to a single images. So, and then by a print function, I want to see that how many Landsat data are available for 2023 Landsat 8 images based on the time extent already selected. So print Landsat 8, and in the right panel you can see the results by the map.center object. Google focused on the study area that already by the rectangle selected, and here you can see that 184 elements are available. 184 elements are available. It is a single image collection, and also each image is an element in the image collection, and you can see that in each date surface reflectance images and also surface temperature image are also available. So, and in the next part I'm gonna call Landsat 9 images for the same period of time. So make a new variable, Landsat 9 equals to find appropriate collection for Landsat 9, you should also select Landsat 9 Collection to level 2. For now, when you are working with Landsat images, you should use Collection to level 2 because it is already corrected and no need for further processing. I mentioned before, Collection 2 level 2, Landsat 9. Yes, level 2 collection 2 tier 1. Just like that, import it into the code. It is image collection number 2. Then we assign image collection number 2 to Landsat 9 variable, and then define filter date and filter bound. Just like that, time starts. When we make a variable for the start time and end time, you can see that no need to repeat the dates again. Just one time you can change the dates and then go for further processing without any trouble. So, and time start and time end selected, and then we bound the Landsat 8, Landsat 9 images for our study area. It is geometry, and then print to see how many Landsat 9 available for the New York City in 2023 actually. As you can see that only, it is 179 elements are available, and a large number of Landsat 9 images available for this period of time, and also we can use these kind of products together to do further process, and also it would be very helpful. But before that, when we are going to make monthly collection, it would be better to filter those of images that highly covered by the cloud, and here it would be better to set a new filter for the cloud cover situation. So make a new code, earth engine.filter dot less than dot filter dot lt means less than. I want to call those of Landsat data in which cloud cover is less than, for example, 25%. Because if we pick, for example, some numbers such as 10% or something like that, the low number of images are available. So in order to have enough data to make monthly product successfully, we need to set a mid-range for the cloud cover. And as you can see, there is a property here which is cloud cover, and when we copy and paste it here, we can call those of Landsat images with cloud cover less than 45%, like this. And then I copy this code to the next line here for Landsat 9 again, and run the code again. 179 reduced to 98 images only. And also for the Landsat 8 images, 111 images are available from the Landsat 8. Okay, now I'm gonna to merge Landsat 8 and Landsat 9 data together in a single image collection. It's very important technique. Just you can do it very simple in the Earth Engine platform. So here I make a new variable, Landsat Collection, like this, equals to Landsat 8 merge to Landsat 9. Landsat 8 dot merge Landsat 9. The main purpose of Landsat 9 satellite was improve the temporal resolution of the Landsat 8 data. And also when you are working or using Landsat 8 and 9 together, you can reduce the temporal resolution from 16 days to 1 week or 8 days. And also, so I merge all of them together and then use print Landsat collection. Landsat collection. Try to write the code by your own to learn how to do programming in the Google Earth Engine platform. It's very important to have practice and try and error. When you're writing code by your own, you can learn it very quickly. It's very simple, and it's not a big deal actually for the environmental scientists and also for the remote sensing expert. It is true that we are not programming experts, but it is as simple as we can learn it very quickly and also without any problem. So run the code again. Here we have a 209 elements now because Landsat 8 and 9 combined together from the February of 2023 satellite data are available. But you can see that after Landsat 8 images ends, you can see that at the December 2023, then Landsat 9 images are available. You can see that, yes, here we have Landsat 9 images again for 2023. From the summer, images are available, and also maybe the dates not sorted very well because we have for the same dates maybe we have different images from the from different pass and row, and it would be better to sort all of these data based on the system time start actually as important property for the time series data analysis. So to sort the data based on the date, so here add a new code to the Landsat collection, sort them based on the system time start property, just like that. And then when you write it, when code is run, you can see that all of the images are available from January 2023 to December 2023. Now the data are sorted, and now we can use it very regularly for the further processing without any worries about the differentiation or any misconsistency between the dates and the sequence of data actually. So in the next part, now I'm gonna convert this collection to the monthly format. To do this, we need to make a new function that's already published by the Google developers on the net, and here I'm gonna show you. This function can have different names, for example, temporal composite, temporal collection, whatever you want. You can pick your desired name that you need. So I make a new variable, or you can make a new function just like that without making new variable. But this function including different arguments. One of them is image collection that we want to use as an import, and the start time, the time in which the data started, and also the count, the number of images we need. For example, when we want to get monthly images for 1 year, count will be 12. And also when you want to get monthly images for 2 years, the count will be 24, because each year covered by 12 months, 2 years, we have 24 months. So, and also the interval means the period between the time start and time end, and the interval or temporal frequency of the satellite data. For example, when we want to make the monthly data, the interval would be 1, and also the unit will be months, just like that. But here this function need name. For example, its name is Temporal Collection or Temporal Composite. This function not produced by mine. It is available on the net and developed by the Google developers, and just here I'm gonna show it with you to show that how it works, and also how to use it for your own process in the Google Earth Engine. It's very valuable assets to do your own analysis here. So, and also it's very applicable and enables you to make different kind of temporal collections in the Google Earth Engine platform. First of all, we make a new variable to define a list of the empty list from the output that we want to have. Its name is sequence earthengine.list, just like that, earthengine.list.sequence. This list started from 0 to the number considered to the count, earthengine.number count dot subtract to 1. It's very important to subtract count from 1 because the start is 0. For example, if we need 12 output data, finally from 0 we will have 13, because from 0 to 12 we have 13 number. But if we subtract it from 1, we will have from 0 to 11. It is 12 number for monthly data. And then we need to convert a start as one of the arguments to the date format. So make a new variable entitled origin date, like this. Origin date equals to earthengine.date is a function to convert a start from a string to the date format. Now we need to return the sequence or list.sequence already created into an image collection, earthengine.image collection. As I mentioned, sequence returned as a collection, and then for each row of sequence we need to repeat the same processing by map. Here we have a function, each row in the sequence considered as an I, and here for each row we can define a start date and a start time. So start date and start and end date. Actually, start date equals from origin date dot advance. So there are different arguments. By pressing Control and space together, it will be shown by you. So, and instead of delta, we have earthengine.number interval, and unit will be same, and remove the time zone. It's optional. Repeat this code again for the end date with a minor change. Origin.date.advance interval, well, I missed something here, dot multiply I. It should be implemented on each row, the interval actually. And again, we try multiply.I dot earthengine.number, I consider it as a number, plus 1 dot add 1 to cover the time start or start date and end date together. So now code returned the final image collection, the input collection we defined will be returned here for a period of time that is defined by the start date and end date. Start date and end date. For this period, for example, we need to get an average, that's mean. If you want to get the sum, you can write sum. It doesn't matter which kind of mathematical operation or statistical operation you are using here. It depends on your target. For example, my target is to get cloud-free monthly images. I can use average or median. In the image processing, if you get median over a specific period, such as a week or a month, the satellite the final images will have less cloud on the image in the images, and also it's very important to use median instead of the mean or average. So now we need to set system time start and system time end as important properties for the further time series analysis. Here I set system time start as start date with millisecond format, and then set system time end for end date with millisecond format, just like that. It's very easy to use function. If it is hard for you to write this function in your own code, you can copy and paste it in your code and use that for different purposes. So here, no need to semicolon here because it is not a variable, it is a function. So now I want to get the median of each month from Landsat collections that is included Landsat 8 and 9 for 2023. So here I make a new variable, Landsat monthly equals to, the function name is Temporal Collection with 5 arguments. Copy and then paste here. Temporal Collection is the name of the function. Instead of collection, you must insert Landsat collection or the collection of images that you are using. The start will be time start, already defined here, time start, and the count depends on your purpose. Here I want to have monthly images for 1 year. 1 year included 12 months, so the count will be 12 and 12 1 month images. 1 instead of interval, and instead of unit we will have months. So get Landsat collections by Temporal Collection from the time start and return 12 1 month images. Each month it will get the median value. The median compared to the average included less cloud cover in the final images. So now I want to print the results, Landsat monthly. So now we have 12 elements, and you can see that from the January to the February, Landsat data are available, just like that. But here I want to extract land surface temperature from each month and plot it for you. So to do that, make a new variable, temperature, entitled as temperature, and then from Landsat monthly collection we select only surface temperature B or band number 10. Copy and paste it here. If you go to the description of Landsat Collection 2 level 2, in the bands description, you can see that STB10 with this scale and factor showing the surface temperature, and also it is already corrected and computed. Just you must implement this scale and this factor number by multiply and add. It's very simple. Using a function, we can implement the scale factors to convert the LST to the Kelvin, from digital values to the LST. Here I make a function. Each input images is considered as an IMG, and then I make a new variable as a band. Each image that multiply a scale number. The scale number is this. Copy and paste, and then implement or apply the factor value which is 149. So now we have LST based on the Kelvin value. This is an equation that converted LST from digital number to Kelvin value. So if you want to have it in Celsius, make a new variable, Celsius. The image which is in Kelvin subtracted from 273 minus 15. This is a constant number that we can use to convert from Kelvin to degree Celsius. And then return Celsius results with the system time start and system time end. These properties are important for the time series analysis. System time start and system time end, just like that. So if I print again, you can see that again the code returned 12 elements, and each element included one LST images. That is here. And if you want to see the date of each images, it's very simple. By the user interface.chart, we can show you each image belonged to which date. So I make a chart here by user interface chart image dot series. So the temperature, the region is geometry instead of reducer. For the study area, we want to get, for example, the average of a study area, the average temperature of a study area. And the scale is 100 because thermal infrared band in Landsat images is 100 has 100 meter spatial resolution. And X property is that property explaining the temporal characteristic, which is system time start. It is really necessary property for the time series analysis in the Google Earth engine. So as you can see here, the monthly temperature image is available January 1st, February 1st, March 1st. It is monthly and available with the Celsius format. You can see that it is available. Now also we can show it the final images here by the map.add layer. Using map.add layer, I want to show 12 monthly LST images by two bands. I convert image collection from a collection to a temperature stack bands, and then I clip it based on the region of the interest, which is geometry, and I leave the visual characteristic empty, and its name is temperature. I pick the temp for that, and then I use false at the end because I want to show the result whenever I want. So click run again, remove geometry imports, and open the setting. Here there is the first image for the January, for example. Maybe there are cloud covers in the first images for the January because it is a little high latitude here, and also maybe the rate of clouds is high in the final images, and also we can't see the study area completely good. For example, here you can see that only a part of the region is available for this region, because we had a filter. We had a filter of, for example, 45% cloud cover, and maybe there were no images in this mount with less than 45% cloud cover for the rest of the region. But we can try for those of months that cloud cover is less than January or winter. For example, in July, it is in August, because it started from the 0, the image number 7 belonged to the August. But here you can see that all the region covered completely, but because of the cloudy situation, still we have some effects of the cloud for this region, and you can see that the urban area showing brighter and with a higher temperature. So now we can use this code for another region. For example, I try the code again for a new region, Lisbon in Portugal. You can see that it's very, very good. Monthly images are available for any region of the world that you want to use. It's very helpful.